Okay, we are going to start by identifying the intercepts. So I'm looking specifically at the x-intercept and the y-intercept. Now, the x-intercept means when we look at this piecewise function, where does it touch the x-axis? This is one location, and this is the second. They both have a closed dot. So one x-intercept is negative 10, 0. The second is at 0, 0. Now I'm going to do the exact same thing for the y-intercept. So we're looking along the y-axis. And just as a reminder, x-intercepts have at most one y-intercept. So sometimes there's confusion here. Aren't there two y-intercepts? This is an open circle. It's like if you took your pencil or pen and you stabbed a hole through the paper. There does not exist a point when there's an open circle. So we have one y-intercept at 0, 0. Now we're going to go on to the domain. The domain, we are going to look on the x-axis, and we're going to go always from left to right, describing where is the function. I would like you to take this piece of the piecewise function and extend it. Okay, so I'm going to start here on the x-axis. I'm calling this the x-bridge. And I look up or down, only up or down, not to the sides. We look straight up or straight down with our binoculars, and we see some part of the function. And we could do that at negative 20 or negative 30. We go to negative 7, we see negative 5. Now, at negative 4, instead of looking up because there's a hole, I will find the function down below. Down below is for negative 2 and positive 2, 5, 7, 10, 20, all the way across. This is going to be continuing to be horizontal to the x-axis. So the entire way from left to right, we see some piece of the function. I think one of the top 3 most confusing pieces is the range for students. There's multiple ways to look at this. We're going to look at it in 2 different ways today. So although we don't see here's a 6, 7, 8, 9, let's go down to negative 10 and mark it off. And then we're going to take and do a 90-degree rotation with negative 10 on the y-axis off to our left. Now, a really common mistake is that students say, if I just extend this, students say they're at negative 11, and they'd say, if I look up or down, I see nothing. And I can definitely see where you'd think that. You're like, I don't see anything if I look up or down. But this arrow, if it keeps going, do you see how eventually this would be in your sight? And that's going to keep going in that direction. It's going to be, as it goes to the left, it'll be endlessly going up and to the left. So my range goes from negative infinity, then I'm going to pop back to the y-axis, and I'm going to start walking. I start walking, I can see it. I can see any piece. And then when I get to a y value of 3, I stop. And this is confusing. Students are like, do we include 3 as part of the range? Well, we cannot include this part because it's an open circle. We cannot include this part, but we have all of these points. So yes, we do have points when y equals 3. And for that reason, we need to put it in brackets. Let's look at this another way. So let's look at this maybe the way you have previously learned. I want you to take your pencil or pen and put it down below here. And we are going to analyze the range, which is y values, from bottom all the way up to the top. This says you can go as low as you want, and you will always see some part of the function. This is true. We always see some part of the function. And it says only stop when you get to an x value of 3. That's true. When we get to an x value of 3, we stop. There's nothing up above. And yes, we do see points at x equals 3. So we have done the intercepts and the domain and the range. This is often a confusing one for students. Most students feel pretty confident. Brittany, can you shut off one of the lights for me, please? Most students feel pretty confident about mapping. That may be a new term for you, but it means we are going to find this always represents an x value. We find where x equals 1, we go straight up, and we say f of 1 maps onto a y value of 3. I find x equals negative 4. X equals negative 4 is here. And I can see initially you're like, do I go up or do I go down? We have to go to where there's a point. There's no point up above. It's an open circle. There is a point down below. So f of negative 4 maps onto a y value of 6, 7, 8, negative 8. F of 4. So here's f of 4. I go straight up. and I'm counting 1, 2, 3. We can see that across here. So f of 4 maps onto positive 3. We're going to go over to the side here, and I'd like you to make one of these curly brackets and write x values. We describe positive and negative intervals for f of x along with increasing, decreasing, and constant intervals, all in terms of x values. These are like two different things. This is new to us. We learned this yesterday. You have to read the graph from left to right. So from left to right, it's increasing. I'm going to put an I. From left to right, it's increasing. I'm going to put an I. From left to right, it's flat. It is parallel to the x-axis. It is constant. I believe most students feel pretty confident with that part. What they struggle with is how do you correctly mathematically describe this in terms of intervals. So let's go back down here to the increasing. We have two different increasing intervals. Yes, I always tell you that all of these have to only come with parentheses, but I want to explain it. If you understand it, you don't have to memorize that. So let's go with increasing. You can jump on this hill anywhere. You can jump here, here, anywhere you jump on this hill. If you look at it from left to right, you're constantly running. So you ready? I have, I don't know, Jose. He jumps on the hill right here. And from left to right, he is running. And so if I told you, okay, what's happening at negative 10, you're like, Jose's running. What's happening at negative 6, he's running. What happens when he gets up to this point? Is he running at this point right here? He stops. Did everybody hear that? He stops. When they're saying increasing, it's like running uphill. So we need to describe exactly where you're running uphill. So it comes from the very far left, so you can go as far as you want, and this will always be going uphill. But when you get to negative 4, you're no longer running. You have stopped. And for that reason, we put a parenthesis. If we put a bracket, it would mean it's still running. Not it, sorry. Okay, let's go with this one right here. You ready? So Yvette, thank you for allowing me to use the example. So down here at this interval that is increasing from left to right, when Yvette is at negative 4, is she running right now? Is she going uphill at this point? No. Since she's not going uphill at this point, at negative 4, I put a parenthesis. Is she running all along here? Yes, she's running uphill, running uphill, running uphill. When does she stop? When she gets to an x value of 0. And again, at the end points, she's not running uphill. It's in between that she is running uphill. It's in between that she's running uphill. This particular piecewise function has no decreasing or negative slope, so we're going to write NA. Where is it constant or flat to the x-axis? It's this portion. Again, I believe most students can now identify where it's increasing, decreasing, and constant. It's how do you correctly write it. So what x value does it start being constant at? It starts being constant at 0. But at 0, are you actually running on a flat ground? No, you haven't started yet. So for that reason, it's a parenthesis. And then as you move to the right, you continue to be on this flat surface running. For that reason, increasing, decreasing, and constant intervals will always, always, always use parentheses. So what I start to tell students is anytime you have to do these, just start with parentheses. Right away, parenthesis, parenthesis. It is different for positives and negatives. Although we are going to use x values to describe these intervals, we will use brackets occasionally. So what does this mean? Above where you see f of x, please write y values. We are moving on right now. We have 2 sections left for this problem, and the first one is going to be, we want to identify where on the graph are the y values positive. Please put a box around positive and negative. If you like to think of it as a street or a walkway, there is a portion on this graph that separates where y values are positive in gray on this graph and where y values are negative, which are yellowish brown on the graph. And that is this portion. This axis separates where are the y's positive and where are they negative. I would like you in your paper, assuming you don't have colored pencils, to make a squiggly line across the x-axis. On the x-axis, we know y equals 0. 0 is a neutral number. It's neither positive or negative. If you have $0 in a bank account, you're not in the hole, you're just not above. You haven't added anything to it. Okay, so where are y values positive? I'm going to use a highlighter, and I'm going to mark the two sections of the graph. So this part is above the squiggly line, but it's still in the gray. And this portion is above the squiggly line and in the gray. I have two portions that are positive. Now using a different color, I'm going to illustrate where we have negative intervals. Now, some students get confused. They're like, but isn't this all one portion? It is. But it's like I took a scissors and I cut it right here. It's a piece of string. And I cut it to separate where is this portion positive for y's and where is this portion negative for y's. So let's get started. There's not much room here, so I'm going to come down below and I'm going to say f of x positive and f of x negative. Where is it positive? How do I describe this? So we always go from left to right and we use x values to describe it. So what is the x value in which I start to see this particular piece of the graph? It starts at -10. And it continues to be positive all the way to a value of -4. Now here's the part where you really need to analyze. At -10x value, which is right here, would we consider this portion to be positive or negative? And the answer is neither. It's not positive or negative. It's on this neutral line. It has a y value of 0. So I do not want to identify this piece of the orange as being positive. For that reason, I'll put parentheses. It means after I leave an x value of -10, it's then positive. And it goes all the way up to an x value of -4. Now at -4, I have a hole in the graph. So I have to be able to say, hey, this part is not positive. There's a hole there. For that reason, it is a parenthesis. Very similar. The second interval starts at an x value of 0, but because there's a hole in the graph, I put a parenthesis. And as I move to the right, it continues to be in the positive region, which is above the x-axis. These are the two intervals that are written as x values that describe where is a positive. Between -10 and -4, between them, you're right, between them is positive. If I move on from 0, because it's not a bracket, if I move on from 0 and go to the right, it's positive. That is true. Let's do negative. I need to describe this in terms of an x value. So I can see the arrow keeps going this way. What x value describes going to the left and continuing to go to the left? -infinity. So this portion of the graph will continue to be in the negative y value section of the graph until you reach a value of -10. At -10, it's neither positive or negative, but I've been asked to identify where it's negative. Well, this isn't negative, it's neutral. I can't consider it to be a negative. Our last negative interval starts at an x value of -4 and goes all the way to an x value of 0. At -4, is it in the negative region and is it closed? Yes, this is part of the graph and it's in the negative y's. I need to include it. Why is that different? Everything else had circles. Circles or was on a neutral part. And it goes all the way up to an x value of 0, but at 0, you're not negative or positive, you're neutral. Go down below, please, and please write the word end behavior. This is simpler than you think. They're saying go to the very ends of the graph, and they're referring to the x, they're referring to the x's. Go to the ends of the x-axis and tell me the behavior. Tell me what's happening. And one of three things is going to happen. It's going to be going up, going down, or it's going to be staying flat on some y value. Let's look. Go to the x-axis and go to the far negative side. Okay, x-axis, far negative side, and make this large oval. When this piecewise function enters into this oval shape, which direction is it going? The behavior is going down. Don't make the mistake. Now, that's the right understanding, but don't say down. What is the mathematical symbol for going down? Negative infinity. This means go on the x-axis to the far right. This time, when the function enters this region, and we have to describe the behavior in terms of y values, is it going up, is it going down, or is it staying flat? Now, what y value is it staying flat at? What's this level? 3.